you want to build a robot, it kinda has to be a robot. Let's give it a try.
Hi GoBoxers! I'm Nicole and I'm new to the GoBox team. I'm really looking forward to spend some time with you on this Morse code robot. This mission is the most complex so far. Well, I think it is. Maybe you found another one to be harder, but there are many concepts in this one. You've seen the list before, and this time we are really getting to use it. Let's create our message list. It will contain the duration of each of our beeps. It shows up on the stage here, top right, but you can hide it too by unchecking this box. For now, let's keep it visible. You can add things into the list. Thing number 1 and thing number 2. You can verify how many things are in your list with this length block, and empty your list too with delete all. Now that we have our message list, we can start with the two simplest sequences that have to do with the timer. When the robot gets a start timer message or an end timer message, we will be dealing with the timer. On start timer, we will reset it, and we will also start the buzzer by sending a buzzer 255 broadcast message that is full volume. When we receive the end timer, we will put the timer value into our message list by doing an add, and we will also quiet up the buzzer by doing a buzzer 0. It's always a good idea to test your work as you go along. If I click on the start timer sequence, I should hear my buzzer at full blast. But I've actually unplugged my buzzer because it is very, very annoying in the recording. I did test it previously though, and when I click on the end timer sequence, it should stop and I should see a time show up in my list. Let's clean up a little bit over here and empty our list so that we can start afresh. We are going to tackle our finite state machine. So if you remember from before, it is a complex structure that has a bunch of ifs in it, but at the top we will have an event. Our case here, it will be a keyboard event, and we've chosen the letter R for record. We also need a variable that will help us keep track of the state of the button, so we will call it state, making sure that it starts at 0 and that we have an empty list at every time we start recording. That way we can reuse our program if we want to. At this point, we need to go into a loop. We will be repeating the code until the user says that he or she is done by pressing the letter X for exit. And here is where we will add our complex if statements. So we start with an if-else, and inside of it also an if-else. So what is that? The first one will test whether we have oh yes, I did forget. We are going to start a new broadcast message for the button. We need to read what the button state is. So we will be broadcasting button 15 because the button is on the analog port. It would be button 10 otherwise. And in order to be able to have the button show up as a sensor, we need to broadcast it at least once. And now it will show up over here. See at the bottom, we have a button. So this allows us to test if the button is currently pressed. So take the button sensor value, and it will be pressed if it's equal to 1. No need to trigger it right away. Okay, so the first if is basically the button is now pressed. And we want to handle the case where it is now pressed, but it wasn't before that, because we want the change in the button. So the button was not pressed, and now it is pressed. This is what this if statement here will be. If the state of the button was 0, and the button is now 1, then we start recording. Since we already have the start timer coded, we can just simply broadcast start timer. And everything will be done for us. And in the else statement, basically the button is pressed, but it was already pressed. Oh yeah, let's not forget changing the state, because we need to keep track of the state. Now, in the else statement, let's add a little wait. 0.2 seconds, it's up to you to see how it reacts on your computer, on your Raspberry Pi. 0.2 might be too long, might be not long enough. So the other part, basically the button is not pressed, and the state is that it is pressed. The button was pressed, but it is now released. And what we need now is broadcast the end timer, because we basically want our letter to be done. And let's keep track of the state. Now the state is at 0 because the button is released. And in the else statement, we add in a little wait, and we are ready to test. I've unplugged my my buzzer. There you go, first one, and the second one. They work pretty well. Let's move on to our transmit code. As expected, it starts with the event when I receive transmit. We will need a variable to keep track of our position in the list. So let's call it item. It will contain the index or the number of where we are, 1, 2, or 3, but we'll start it at 0. We also need a loop, and we need the loop to go over the exact length of the list. Inside the loop, we need to change the item variable by 1. On the first pass, it was 0 before getting into the loop, but right away we change it to 1, and eventually to 2, and it will keep on counting. Let's start the buzzer and wait for the appropriate amount of time. That is the value of what is in the list. That's how long we pressed the buzzer for when we recorded our message. Turn the buzzer off and wait a bit before going on to the next one. And with that, our mission is complete. I'm really proud of you. This was a hard one. And if you have it all under control, here's a challenge to you. Right now, we wait half a second between each beep. But this silence is supposed to be short between beeps, a bit longer between letters, and even longer between words. Can you think up a method for this? Here's a hint. You might need a second list. There are many possible approaches to solving this challenge. Have fun!